Hello everybody, this is Cap here with the 27th video in my beginner C++ tutorial series. In this video we will be covering references. Now we've seen references before when we were passing by references in one of the previous tutorial videos, but references are also their own thing. You can do more than just pass by reference. And references are mostly considered to be just aliases for objects. So if we made a poly A object and then made a poly reference, which will say B, and you say you want it to be a reference by preceding the name with an ampersand, just like you would, a pointer, except instead of an asterisk you put an ampersand, and we'll say equal A. So now B can be used as if it were A. So we can say B dot num1 equals 20, and that's perfectly fine. It's used, you can use it as if it were A. So now we can come down here and say cout A dot num1 and L, save it and run it. And as you can see, it changed it to 20. But you can also return references as well. Get rid of that, and we just come up here, say poly, and we want to return it as a reference, so we say ampersand. And let's just say funct. Come down here, and we're going to create a dynamically allocated object. So we'll say poly p equals new poly, and we'll say p num1 equals 40. We're going to return dereferenced P. So we're going to return a reference to the object that P is pointing to in the heap. So down here we're going to say a poly reference, we'll just say B again, is equal to funct. And now we can just say, B dot num2 equals 30. And we'll say cout B dot num1, put a space in there, and B dot num2 and L. So you guys might be thinking, oh, this is great. So now I can, dynamically allocate objects and then pass them out as a reference and use them as if they were objects. Well, that's true, you can, or use them as if they were the objects themselves. But the thing is that if you do that, then you can't tell by the syntax that it is a dynamically allocated object. See, it's easier when you're working with pointers because pointers are mostly used with dynamically allocated objects. But if we save this and run it, so you can see two poly objects were created, but only one was destroyed. So we still have to delete this. And that's kind of tricky to know. Sorry about that, I forgot the ampersand sign. But it's tricky to know that this is dynamically allocated because you're accessing it just like it was, an object, not like it's an alias to an object on the heap. So that is something you really have to watch out for if you want to try and do something like this. So, what's the difference between pointers and references? Because, you know, references seem to do the exact same thing that pointers do. They take an address of an object, but unlike pointers, you can use them as if they were the object. And most of the time, references are implemented as pointers by the compilers. But they have more rules that, you know, most people would consider to make them safer to use. And that is that references must point to an object. They cannot be null. Therefore, you eliminate the risk of dereferencing a null pointer. So, like if I tried to do something like this, can't do it. It has to be pointing to something whenever you create it. And another thing is that you cannot take a reference and point it to something else after it's created, unlike pointers. So you cannot reseat references like you can pointers, which would also make them, you know, considered to be safer to use. And those are really the two biggest differences that, you know, people talk about. Or, you know, the things people say to consider when you're trying to decide whether or not to use a pointer or reference. In general, you're going to want to use references. In my opinion, you would want to use references as often as you can unless you have to use a pointer. And that's pretty much all I wanted to cover in this video. So if you like this video, hit the like button. If you have watched a few of my videos and really like them, go ahead and subscribe so you can see when I post new ones. And I would like to thank you for watching, and I'll see you in the next video.